Hi everyone, today we will be doing the lab 6, which is the Coulomb's law. And by definition, Coulomb's law, which you can see also in your lab manual, equation 6.1, and which is describing the properties of the electromagnetism law, which is directly proportional to charges and inversely proportional to the square of the radius. And today we'll be doing two parts of the experiment to verify the correctness of the Coulomb's law. And for the first part of the experiment, we'll be testing the varying charges of the Coulomb's law. And then for the second part, we'll be testing the varying distance of Coulomb's law. And for this part of the experiment, you'll be using a power supply like this one to be the power supply. And there will be two sets of apparatus. There's the sliding apparatus and there's the charging apparatus. And this is the Coulomb balance, and which you must maintain the two slides to be collide with each other. Because we want to measure the forces, electrical forces to the machine. So, by definition, if the forces are larger, the torsion angle over here should be larger too. In your post-lab session 4.2, you'll be measuring the relationship between forces and separations. For the first part of the post-lab experiment, we'll be doing the session 4.2, which is examining the relationship between the force and separation distance. And by doing this part, we'll be examining the effects of the 1/r squared in the equation 6.1. And to doing this, we will be sliding the sliding spur over there to variable distance as required by the table 6.1, which will be 12, it will be 20, 14, 10, and so on. And for this part, we will be setting the power supply at 6 kilovolt at all. And now we are trying to exert some point charge at this spur and slide it as required by the post-lab to 20 centimeters. And now we have to turn the torsion until we see the two planes collide with each other again. It is to measure the effect of the electrical forces.
Now that the two ticks have lined up in the back, we will now write down the angle at the top of the torsion wheel.
After each recording, we will be turning the machine back off and to charge each spur and slide it to the maximum distance and proceed further to the smaller distance. And this time, after charging the spur, we will be sliding it to 14 centimeters. And now we slide it to the 10 centimeters. Now it's 9 centimeters.
Do note that for each measurement taken, we'll be running 3 trials for each so that we can obtain a theta average for our calculations.
And now we proceed to extend the meters. And now it's 7 centimeters. Now we slide it to 6 centimeters. And for the last, we slide it to 5 centimeters. For the entire procedure, we have to obtain we have to repeat the same procedure for 3 times to obtain the theta average. And and for the rest, including the beta corrected, and which all the equation can be found at the section 4.1 of your post lab manual. And this is the part of what we are doing in the first part of the experiment. For the second part of the experiment, which is the section 4.3 in our post lab manual, we will be measuring the effect of forces and the variable charges. In this part, the procedure is very similar for the first part of the experiment, except now the sliding spur should be always slide to X centimeters. And the sliding spur, the charge is always exerted as 6 kilovolt. But for the sliding spur, we will be varying the charge exerted on it by varying the charge from 6 kilovolts to 1 kilovolt. And now we are trying to do this. And we are trying to exert both of the fixed charges. The sliding spur to both of these should be charged at 6 kilovolts. And now I'm starting to X centimeters. The most important thing for the experiment is that we are always charging this spur at 6 kilovolts. But from now on, we are trying to vary the charges of the sliding spur is down to 5 kilovolts. And to slide it to X centimeters again. This is because we only want to measure the varying effects of Q for one, but instead we don't want to measure it as Q squared. Now we charge the sliding spur to 4 kilovolts. we charge the sliding spur at 3 kilovolts for this step. This time we charge the spur at 2 kilovolts. Lastly, we will charge the sliding spur at 1 kilovolt. And this time we will be charging the sliding spur at 1 kilovolt. And similar to the first experiment, we will be repeating all the data collection 3 times to obtain the data collected. And all the data will be provided for you. And you just have to do the last part of the experiment. And I think this is the all of the lab.